Supercritical steam generator. A supercritical steam generator is a type of boiler that operates at supercritical pressure and temperature. It is frequently used in the production of electric power. Supercritical water. Supercritical water exists at temperatures above 374 degrees centigrade and pressures above 220 atmospheres. In contrast to a subcritical boiler in which steam bubbles form, a supercritical steam generator operates above the critical pressure 22 megapascals, that is 3200 psi, and temperature 374 degrees centigrade, that is 705 degree Fahrenheit. Under these conditions, the liquid water density decreases smoothly with no phase change, becoming indistinguishable from steam. The water temperature drops below the critical point as it does work in a high pressure turbine and enters the generator's condenser, resulting in slightly less fuel use. The efficiency of power plants with supercritical steam generators is higher than with subcritical steam because thermodynamic efficiency is directly related to the magnitude of their temperature drop. At supercritical pressure, the higher temperature steam is converted more efficiently to mechanical energy in the turbine, as given by Carnot's theorem. Technically, the term boiler should not be used for a supercritical pressure steam generator as boiling does not occur. Request: it is hoped that this session is going to be useful to you. Please press like button. Please subscribe this channel. Definitions: subcritical up to 705 degree Fahrenheit, that is 374 degree centigrade, and 3208 psi, 221.2 bar, the critical point of water. Supercritical up to the 1000 to 1050 degree Fahrenheit, that is 538 to 566 degree centigrade, requires advanced materials. Ultra supercritical up to 1400 degree Fahrenheit, that is 760 degrees centigrade, and pressure levels of 5000 psi, that is 340 bar. The term advanced ultra supercritical or 700 degree centigrade technology is sometimes used to describe generators where the water is above 700 degree centigrade, that is 1000 292 degrees Fahrenheit. The term high efficiency, low emissions has been used by the coal industry to describe supercritical and ultra supercritical coal generation. Here we are showing subcritical oblique supercritical cycle on a temperature entropy plane. Subcritical cycle starts from 1, goes to 2, then 3, then 4, then 5, then 7, then 8, 9 and back to 1. Whereas supercritical cycle goes from A to B to C to D to E to F to G, then H, I and back to A. Rankine cycle subcritical unit. From point 1 to 2 is condensate extraction pump work. From 2 to 3 is low pressure heating. 3 to 4 is boiler feed pump work. 4 to 5 is high pressure heating. 5 to 6 is economizer and water valve. 6 to 7 is superheating. 7 to 8 is HPT work. 8 to 9 is reheating. 9 to 10 is intermediate pressure turbine work. 10 to 11 is low pressure turbine work. 11 back to 1 is condensing. Rankine cycle supercritical unit. From point 1 to 2 is condensate extraction pump work. 2 to 2S is regeneration. 2S to 3 is boiler superheating. 3 to 4 is high pressure turbine expansion. 4 to 5 is reheating. 5 to 6 is intermediate pressure turbine and low pressure turbine expansion. 6 to 1 is condenser heat rejection. Feed water control. In drum type boiler feed water flow control by 3 element controller, in which 3 signals are used: drum level, main stream flow and feed water flow. In drumless boiler feed water is controlled by water/fuel ratio. Here is a chart showing comparison of supercritical and subcritical steam generation. The main point to be noted here is the specific coal consumption. In case of supercritical, it is low, that is around 0.6 kg per kilowatt hour. In case of subcritical, it is high, of the order of 0.68 kg per kilowatt hour. It is continuation of the same table. Main point to be noted is overall efficiency. In case of supercritical, it is high, 40 to 42%, and in case of subcritical, it is low, between 36 to 37%. Continuation of the same table. The main point to be noted is that supercritical, in case of supercritical, the boiler is drumless, and in the case of subcritical, it is a drum type of boiler. Advantages of supercritical technology. The main point to be noted is less fuel consumption. Economy. In case of supercritical steam generation, the main point to be noted is higher efficiency and less fuel input. Increase of cycle efficiency due to steam parameters. Here we can see that as the pressure is increasing and as the temperature is increasing, the increase in efficiency is maximum. Challenges of supercritical technology. The main point to be noted here is water chemistry is more stringent in supercritical once through boiler. Carnot cycle. Here for your ready reference, we are talking about Carnot cycle. Here we are showing Carnot cycle in a pressure volume diagram. From 1 to 2, it is reversible adiabatic expansion. 2 to 3, it is reversible isothermal heat rejection. 3 to 4, reversible adiabatic compression. 4 to 1, reversible isothermal heat addition. Here we are showing Carnot cycle diagram in temperature versus entropy graph. In a Carnot cycle, a working fluid takes in heat reversibly from a reservoir heat source at a constant high temperature T1, expands adiabatically and reversibly to a constant lower temperature T2, gives up heat reversibly to a reservoir heat sink at T3 equal to T2 and is then compressed reversibly and adiabatically to its original state T4 equal to T1. Equation shows that efficiency of the Carnot cycle depends on the temperature of the heat source and heat sink only and is independent of the type of working fluid. Higher the temperature of the heat source, the lower the temperature of the heat sink, that is, wider the temperature range, the more efficient is the working cycle. This cycle also establishes that this is the maximum achievable efficiency a heat engine may attain. In a real cycle, however, cycle efficiency will be always lower than the Carnot cycle efficiency. Request: it is hoped that this session was useful to you. Please press like button. Please subscribe this channel. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा.